Hi, my name is Mario Martinez, and I'm gonna be talking about the requirements module in the LATAM study cycle BI project presentation on behalf of the studies of the GAPS BI team. Requirements are the start of the project and is, in my perception, the most important piece in any project. If we don't have solid requirements, we have a flow or a bad application, because if it doesn't respond to the user needs, then even if it's a great performant application, it doesn't fit the requirements, it means that the users won't use it, and that's basically a failure. Now, this project in the requirements phase we have invested a lot of time. If we go to SVN, in our internal SVN repository, we got a whole section, a whole folder for requirements. Here we got all this documentation. Here is basically the records of the information taken from different great people that I personally have interacted with in a study cycle. I'm talking people from the regional, Miami regional office, Latin regional office, all the way to people in the field. I mean, from the different countries. Especially we want to recognize the effort that has been put by Luis Barbero at the regional office, Gustavo Di Mari, and Andres Sepúlveda from Chile, and Gustavo Di Mari from Argentina. But here, if we go, we have all these gentlemen and ladies that we see over here has contributed to this. A lot of people have contributed to this. In each of the folders, we have basically the information that I have gathered from the different stakeholders. Basically, everything is here. This is the raw source of the requirements. Now, out of these interactions, we have created a document that is the requirements document, right? Which is the one that I'm showing in the screen, right? And that document is the one that is being or basically has driven all the design and development in this BI solution. Okay, so the structure of this document, which is basically the point of reference, let's say this way, for any different stages in the business in the implementation cycle, is basically we had a section where we talk about the general aspects and what are data warehouse design. This is for the readers that want to go a little bit deeper. So those are concepts that are basically extracted from the Kimball methodology of data warehouse design, and it's basically the intention of this section is to so that the rest, some terms that shows up in other sections of the document don't seem foreign to the reader. But again, it's not necessary to get a hold on the rest of the document. It's just for the readers that want to go deeper. Okay. Now, the next section basically talk about the business matrix, and that's, in my perception, is the most important piece of the document. It's basically lay out what are the different business processes that a study cycle has right now, at least in LATAM. And it's an intersection of all those different business processes with the different dimensions or set of attributes that are grouped by the same semantic meaning. The intersection of those dimensions with those business processes. I'm going to be talking about what is a dimension very soon right now. Then next, we are going to be basically talking about what are the main dimensions and the detail of each of the dimensions. I mean the attribute that make up these dimensions. Later in the document, we have a section for each of the data marks, for each of the data schemas, which is basically an intersection of those dimensions, right, for a given business process. So for us to be able to dig into an example of this, let's talk first what is a star schema. Okay, a star schema is basically, it's pretty similar conceptually to what we know from Excel as a pivot table. Okay, so let me see if I can pick an example here. When we go to Excel, for example, and we open Excel and we create the connection, and we basically create the pivot table, right, in Excel, we notice that we got a section where we can drag and drop dimensions or attributes, right, and another section that we can put in the pivot table aggregated values, right. Well, the dimensions, I mean, those attributes are analogous to what we see over here in those squares, right. So basically are the adjectives or the descriptions that we can use to slice and dice the data, and by data I mean the aggregated values are basically the counted or measured values. For example, in this particular star schema that I'm showing in the screen, we got all these dimensions and that intersect in the middle the granularity of 1 day period, and the measures that are right here in the intersection are the new contracts, the active contracts for that day, the non-active contracts, the finished contract, and the dated contracts. This is an example. The rest of the star schema are very similar in the structure itself, although they are referred to different business processes. Now, given that, let's talk about what is the BOS or the business matrix, which is basically the most important piece in this document. The business matrix, which is represented over here by this diagram, is basically, it's a matrix, right? Has two dimensions. Has in the rows we got the different business processes, which in this case of the study cycle, we identify these business processes: sales, request, transportation, treatment, and the last is in the second page, is basically, well, not the last, storage, final disposition, and then lastly finance. So all are the different business processes that make up the operations in the enterprise. Now, for each of the business processes, we can have one or more star schemas. For example, in the case of sales, we have defined two star schemas. One that is more granular by nature, and the other one that is less granular by nature. So in other words, this one has more details than this one. This is more coarse. I mean, the metrics are more coarse, and this one is more granular. So in the same sense, we can have multiple star schemas for each of the business process. For requests, for transportation, we only have one. But again, what we have laid out here is for each business processes, or for each business process and each star schema, we see here what are the dimensions that intersect in a visual manner. For example, for sales and the contract transactions data mart, or the contract transaction star schema, we have that the attributes that we can use are coming from the date dimension, the legal entity dimension, the employee dimension, line of business dimension, country, client, payment account, and contract details, which is basically like a very important dimension in this case. So in the same way, any intersection, any green dot over here, mark what are the intersection between the dimensions, which are conformed in the sense that they are common, they hang or they connect to each of the star schemas. They have the same dimensions. That's why they call it conform, because we are talking about the same data that basically can hook up to multiple star schemas. And the convenience of that is that we can basically create reports that span multiple star schema, because we got the connection through those conformed dimensions. Now, regarding the dimensions itself, we have identified these dimensions over here. We got the date dimension, which is going to be present in most of the data marts, right? We got the legal entity dimension, the employee, line of business, the country, the client side, payment account in this is the payment account in Silos. Okay, the contract details, which is basically it talks about very details of the contract that are basically factoring in one place, which is this dimension. And they are not basically measures. I mean, they are not basically aggregated values. They are description of the contracts. Unit of measurement, request details, similar to the contract details, basically aggregate attributes that are common to all the requests, and they are not aggregated. We got a route pattern or route template. Transportation, basically it talks about the trucks and all the different attributes related to a given trip. The operation shift in a plant, the software house, the type of treatment, the equipment. When we talk about equipment, we're talking about oven and autoclaves in the case of a Stericycle. The material, which is basically material, we are talking about the different waste types, the different products that can be obtained out of the recycling process. The currency, and in the finance business process, you notice we got the ledger and the account. Right? You notice these two dimensions are only related to the finance business process. It doesn't touch any other business process because they are very specific for finance. Now, for each of the dimensions, we have a section here. You see, for each of the dimensions, we have the description of what are going to be making this dimension, what attribute, what collection of attributes that are correlated semantically makes up this dimension. For example, for date dimension, we got the date, which is the lowest granularity attribute. We got the number of month, the number of this is the number of the month itself, the start date, the final date, the quarter, and the quarter start date and the quarter final date. Okay. For legal entity, for example, we got the name of the legal entity, the code, right, which is basically the Silos code. If it's external, if it has warehouses, if it can lend trucks, all the different attributes that we see in Silos, we can see it over here too. And so on, right? For the other dimensions, exactly the same pattern. We're basically describing all the attributes that make up the dimension. Now, for the data marts, for the star schemas. And by the way, a data mart is a collection of star schemas that are related to a business process. Okay? For the star schemas, we got again, I'm going to come back to this slide over here. We got a diagram, and that's going to apply for all the star schemas that we have in this document. We have a diagram that basically lay out what are the dimensions that are intercepted in the fact table or in the middle. We got the granularity of the fact table related to the star schema. In this case, it's 1 day period. And we got the different metrics of facts or metrics that are related to this fact table in the middle. Okay. So a star schema has dimensions and has a fact table in the middle. The fact table is represented by a circle, and it has the granularity. Basically, granularity here means what means one row in the fact table, and then we have all these dimensions that are hooked up to the fact table. And in the fact table, a row in this fact table has all these facts that basically are metrics when you aggregate it. We got new contracts. This is a specific case, but if we go to a different one, we're going to see that it's different. For example, for the request, right? For the request star schema, we see that the granularity is one request, that what one row in the fact table refers to, and we got metrics related, for example, to the estimated time of the scheduling, the time taken for scheduling, the time taking achieved. This is the real time achieved. The difference between achievement and scheduling time, the difference between estimated scheduling and scheduling time. So all those metrics, I mean the semantic meaning of all those metrics that we have here in the description are basically derived from the interactions, the great interaction that I had with all the different people that I study cycle. So this document is a very important document because it's the reference for anything else that we have implemented, designed and implemented in this project.